variables under radicals. So for this type of thing, you want to separate the numbers inside of the radical through multiplication to things that have square roots and things that don't, right? So 25 as a square root, that's 5. So we would take it out of the radical. X to the fourth as a square root, x squared. And y to the third can be separated to y squared times y, right? So we would take the square root of y squared out, which is y, and keep the extra y inside of the radical. And here we have our answer. Similarly, on the next one, we will separate 27 to 9 times 3. And a to the sixth can be separated to a to the third times a to the third. Similarly, b squared, b to the squared. And we have an extra b. So if we have two of the same thing inside of the square root, we just take it out. So a to the third, and the square root of 9 is 3, and we keep in the extra 3b inside of the radical. Here, we can separate 80 to 16 times 5, and m squared times n, we'd have an extra m, and then n to the 8th would just be, square root of that would just be n to the 4th. So we would take out the 4, that's square root of 16, we would take out m, square root of m squared, take out n to the 4th, square root of n to the 8th, and we keep in the extra 5m. Next one, 12 is just 4 times 3, square root of 4 would be 2, which is why we're doing that. P to the 7th is just p to the 6th times p, and the square root of p to the 6th would be p to the 3rd. So, in q squared, obviously q. So we'd have an extra 3p inside of the radical. So we'd take out the q, p to the 3rd q, and we'd have an extra 3p inside. Our last one, 45, is just 9 times 5. And r to the 5th, we just separate that again into something that's a square root and something that doesn't. So r to the 4th times r. And s to the 4th is pretty self-explanatory. It's just s squared. It's a square root of that. And we take out r squared.